Welcome to the deep dive. We're your shortcut today to really getting a grip on some core system administration knowledge.
That's right.
We've basically taken a stack of practice questions, the kind that really test foundational skills, and we're using those as our guide.
Yeah, our curriculum, so to speak.
Exactly. And the mission here is simple. Pull out that key knowledge you absolutely need about essential commands, how file systems are laid out, and, crucially, the security side of things, the stuff that powers stable systems.
And we're not just, listing answers. We want to get into the why. Why these commands? Why this structure? What's the administrative thinking behind it all?
Makes sense. And just so you know where this material is coming from, context-wise, it's based on scenarios where you need fast, accurate knowledge. Think certification exams, maybe.
High-pressure situations.
Yeah, like maybe 90 minutes, up to 90 questions, multiple choice, some hands-on stuff too.
Performance-based, yeah.
And you need a score of, 720 out of 900 to pass. It's about being ready to do the job, not just talk about it.
And interestingly, being ready often starts with tasks that seem almost mundane. But they're absolutely critical.
Good point.
Like managing the system environment itself.
Yeah.
Files, services, the basics. Let's jump in there.
Okay, sounds good. Let's start with file management. So picture this.
Yeah.
You get a huge compressed archive file, massive, before you extract it, which could take ages. Fill up disk space,
Yeah.
You just want to see what's inside. What's a smart command line way to do that without unpacking everything?
Yeah. The efficient way is to use the specific list contents option for whatever archive tool you're using.
Yeah.
Like tar, DIT, or Ziplo.
Right.
It's basically like asking for the table of contents, the manifest. You see the file names, maybe sizes, paths.
Without actually writing all that data to disk.
Exactly. It's quick. It's an administrative check. Do I even need this is what I think is actually in here.
So it saves time, obviously, but also disk I/O. And I guess maybe security risks, too. Extracting unknown stuff blindly seems like a bad idea.
It absolutely is. Every extraction is a potential risk, however small. And just clutter, frankly. Good admin practice is about minimizing both, tidy and safe.
Okay, tidy and safe. Let's stick with that theme. Moving from what's in a file to where it lives. File System Hierarchy Standard, FHS.
Oh yeah, crucial for organization.
So good systems keep the core OS stuff separate from user-installed things, right? If an admin installs, say, a custom tool or some extra data files not part of the main OS, where should those logically go to keep that separation clear?
Those typically belong in the local share directory.
Yeah.
Often something like OSO local share or similar structures depending on the specifics.
OSO local, yeah.
The whole idea of the FHS is maintainability. You keep the core OS binaries and libraries clean, untouched by third-party stuff if possible.
So updates are cleaner.
Exactly. Patching, auditing, upgrades. It all becomes a nightmare if you start mixing your custom apps directly into OSRubbin or lib. The local share directory keeps that user-specific non-core stuff neatly partitioned.
Keeps the OS integrity intact. Makes sense.
And speaking of integrity, let's talk about time. System time. Seems basic, but...
Oh, it can cause absolute chaos if it's wrong. Logs, authentication, scheduled jobs.
Right. So if you, as the admin, need to set the system's time zone correctly, not just tweaking the clock, but defining it for a geographical location like America, New York, or Europe, London. What's the standard command line tool for that?
The go-to utility for that these days, especially on systems, is the time date control utility.
Time detect.
Time detect.
Okay.
It handles setting the time zone, enabling NTP synchronization.
Yeah.
It's the central point for managing time settings properly.
And why is getting the time zone definition so critical beyond just having the clock display the right local time?
Logs. Number one reason. If your servers are logging events with timestamps from different incorrect time zones, correlating events across systems becomes impossible. Troubleshooting. Forget it.
Plus, secure connections often rely on time synchronization. Kerberos, for example, is very sensitive to time skew. Scheduled tasks kick off at the wrong times. It's just messy and unreliable.
Okay, yeah, I can see how that cascades. Which actually leads nicely into service health. Let's say one of those critical services, maybe something time-dependent, just stops. Poof.
Yep. The classic, it just died scenario.
And there's no obvious error message spitting out right away in the main logs. What's the absolute first thing you do administratively before you start digging deep?
First step, always. Check the service's status with the system control utility. Usually system catch-all status service name.
Check its status with system catch-all.
Yeah. You need to know what the service manager, systemed, thinks is going on. Is the service unit loaded? Is it active? Is it inactive? Dead. Did it fail during startup? Is it disabled entirely?
So you're checking the intent versus the reality.
Pretty much. This tells you immediately if the problem is at the system level, like a config error preventing startup, or if system tried to run it and the application itself failed internally. You don't waste time hunting in application logs if system tells you it never even got started properly.
Right, first things first, verify the basic state. That clarity seems key.
It saves so much time.
Okay, so we've got files located properly, time set correctly, basic service health checks down. Now, who gets to actually do all this? Let's move into section 2. Privilege, identity, security controls.
Right, the keys to the kingdom, or at least how we manage them carefully. This is all about balancing efficiency with security, letting people work without giving away too much power.
Exactly. And there's a difference between just switching who you are on the system versus getting more power.
Right, a very important difference.
Let's start simpler. A user needs to switch to another account, maybe to run a quick test as that other user, and this is the key bit, they want to stay in their current working directory. They don't want to land in the other user's home directory or inherit a totally new environment.
Yeah. For that specific need, switching user identity while keeping your current location, you'd use the switch user command, su, but often with specific flags to preserve the environment, or just switch the user ID without a full login shell.
So su username might try to give you a full login shell, potentially changing your directory.
Right, but sometimes you just want to be that other user for a moment, right where you are. Su has options, like sometimes just su username without the ORL flag might keep you there, depending on the shell configuration. It facilitates the identity swap without the full context shift. Great for quick, specific tasks.
Okay, so that's user switching. Now, the big one, privilege escalation. An admin needs to run just one command, but as someone else usually root, the super user, crucially, without needing to type in the root password for that single command. This is standard practice now, isn't it?
Absolutely fundamental. This is done using the run as super user utility, which is almost universally sudo.
Sudo. Everyone knows sudo.
Right. And its power is that it grants temporary, audited elevation. You configure who can run what commands as whom, and it logs every attempt. You don't share the root password. You don't log in as root perpetually. You execute specific necessary commands as root, briefly.
So it's controlled, granular, logged access, much safer.
Infinitely safer than passing around the root password or everyone just logging in as root. That's how you maintain accountability.
Okay, but sometimes systems need persistent elevator rights for certain tasks, right? Which brings us to special file permissions. What's the command in the specific flag that lets a regular user run a program, but have that program execute with the privileges of the file's owner again, often root?
That's the change mode utility, chand, used with the set user ID flag, commonly known as SUID or setuid. So do something like chand u plus s file name.
Chmon u plus s, and that s signifies the SUID is set.
Correct. When that bit is set on an executable file owned by, say, root, any user who runs that program effectively runs it as root for the duration of its execution.
Now wait, if sudo gives us controlled, temporary, audited elevation, why would we ever use SUID, which sounds kind of dangerous, persistent elevation?
It is potentially dangerous and needs to be used very sparingly, but it's necessary for certain core system functions. The classic example is the password command.
For changing your password.
Right. To change your password, the program needs to write to protected system files, like it's set of shadow. A normal user can't do that. So password is owned by root and has the SUID bit set. When you run password, it runs with root's privileges just long enough to update that protected file.
Okay, so it's for specific essential utilities that inherently need elevated rights just to function, regardless of who starts them.
Exactly. The danger comes if an admin mistakenly sets the SUID bit on a custom script or a program that hasn't been carefully audited for security. That can create a massive hole.
Right, turning a simple script into a root privilege escalation tool accidentally. Yikes.
Big yikes.
That really highlights the need for even tighter controls. Which brings us to things like Linux Security Enhanced Linux.
Yep, mandatory access control, a whole other layer.
So if an admin thinks a permission problem isn't the old school user group author permissions, but an Linux policy blocking access, how do they actually see the Linux context labels on files and directories? What command shows that?
You need to use the list file utility, LSS, but add the security option. That's typically nata z, capital Z.
LZ.
Exactly. LS shows you the standard permissions, ownership, etc.
Right.
LSS adds another column showing the Linux security context label associated with each file or directory.
And that label is what Linux policies use to decide if process A can access file B.
Precisely. It's not just about who owns the file, but what the policy says about interactions between different labeled entities. Seeing those labels is the first step in diagnosing permission denied when standard permissions look fine. You might need to relabel a file, devgone, or adjust a policy rule.
So it's like another dimension of permissions governed by these context tags.
That's a good way to put it. A critical dimension in secure environments.
Okay, fascinating stuff. Let's shift gears slightly for our last section, moving away from direct system config and security policies and looking at tools that help with, well, logic and teamwork in administration.
Yeah, because admin work isn't just clicking buttons or running single commands anymore, is it? It involves automation, scripting, collaboration.
Definitely. So starting with scripting, you're writing a shell script, maybe bash. You need to check if two numbers are exactly equal. Inside a conditional, like an if statement, what symbol do you use for that numeric equality test?
Inside the shell's test construct, often square brackets or double square brackets, you typically use the equal sign, but specifically the EQ operator for numerical equality.
Ah,
Right.
EQ, not the single or double as like in some other languages.
Well, single is usually for assignment. Double X can sometimes work for string comparison
Right.
inside double brackets, a lot depending on the shell. But for reliable numeric comparison in standard POCX shells or single brackets, EQ is the correct portable operator. So if num$ and EQ num2 hence.
If num$ EQ num2 hens, got it. Using I or there might treat them as strings, leading to unexpected results if you're comparing, say, 0, 1, and 1.
Exactly. Or it might just be a syntax error. EQ is specifically for checking if two integers are mathematically equal. It's a common tripping point in shell scripting.
Good detail to know. Okay, final tool. Collaboration. Teams working on configs, scripts, maybe infrastructure as code, managing changes, tracking history, merging contributions. What's the absolute standard tool for this now?
Oh, that's got to be the Git version control system, hands down.
Git? Not just for developers anymore, huh?
Not at all. It's indispensable for modern system administration and DevOps. Managing etc. configurations in Git, tracking changes to Ansible playbooks or Terraform code, collaborating on administrative scripts.
So you can see exactly who changed what, when, and why.
Yep. And crucially, you can roll back easily if a change breaks something. You have a complete history. You can experiment on branches without affecting the main configuration. It brings sanity and safety to managing infrastructure code and configuration files, especially when multiple people are involved.
A safety net for change. I like that.
It really is. So, maybe the final thought for you, the listener, is to reflect on that balance. Given the convenience and necessity of tools like SUI and sudo for getting administrative work done, how do you weigh that against the absolute need for strict security boundaries, like those enforced by Linux? What does that constant balancing act between convenience and control tell you about managing risk on a modern system? How do these pieces, SUID's inherent power, sudo's controlled access, and Linux's mandatory context work together, sometimes maybe even against each other, to define the real security posture?
That's a deep question. Balancing that convenience, power, and strict control, definitely something to mull over.
Yeah.
Great stuff. Thanks for diving depth with us today.
My pleasure. Always good to talk through these fundamentals.
We'll catch you on the next Deep Dive.